Okay, welcome back for some more fun with math. In this video, I'm going to talk specifically about the complex number system. Now, complex number system is a fancy way of saying imaginary numbers. So in this case, what we're looking at is if we have a negative sign underneath a radical, how do we deal with that? And that is what the complex number system does. There's a couple important rules, these right here, that you need to remember. First and foremost, any negative under a radical sign can be rewritten in the form I. Now the other thing that we need to keep in mind is that if you have I squared, well, that's the same thing as having -1. So you need to make sure when you're working these that you are reducing down as far as you possibly can go. So how does this actually work? So let's say I have the square root of -a. The way I like to do it myself is I would circle my negative here, and I know that this has to pull out of my radical sign as an I, thus changing my radical into being I, then square root of a. The next thing that you would do here is you would simplify the square root of a as much as you can. You want to write your answer as reduced as humanly possible. So once you pull that I out, then the I is along for the ride and it follows you with everything else that you do. Okay? So how does this work exactly? Well, I have the square root of -9. So again, just like before, my negative here is going to pull out of my radical as an I. And what's going to happen is it's going to leave behind I, and then you have the square root of 9. Well, the square root of 9 we know can reduce into 3. So this right here is going to become 3I. Let's look at another one. Again, I have the square root of -24. So here I'm going to take this negative and it's going to pull out as I, which is going to leave me with I square root of 24. Well, we need to reduce 24 down, so we know 24 can reduce into 4 times 6, and we know 4 can break down into 2 and 2. So what actually happens is this is going to give me 2 I square root of 6, or you can write it 2 square root of 6 I. Either method will work, especially in Hawks. However, just make sure when you write it this way, which is the proper form, that your I is outside of your radical. So when you're typing your answers in and you're under the radical, do make sure that you error out of it, or move out of it so that this I is outside of the radical sign. Last here I have the square root of -15, so I'm going to first pull my I out. This becomes I, and then I have the square root of 15. But when we look at 15, 15 does not reduce any. So therefore there is nothing else that we can do with it except for leave it. The other thing that we could always do is write the radical 15 first and put the I off the end. Now the reason why I keep talking about putting the radical first and the I off the end is because we have what's called standard form of an imaginary number. Standard form of your complex terms says a plus bi, where a is the real part of your equation, b stands for the imaginary part. So when we're talking about imaginary part, we are talking about the coefficients or the radicals or variables that we have. And then of course I is always off the back end. Okay? So that is standard form. Now with this, we also have what's called operations with complex numbers. So operations, we can add, subtract, multiply, or divide. So the first thing I wanted to do is I wanted to start with add. And so you can see that the directions simply say that you need to perform the indicated operation. And the way you do that is by essentially combining like terms. So it all boils down to that you have to combine your like terms. So in this case, I have this positive here, which has to flow through my back parentheses just like normal. So I'm going to be left with negative 12 minus 4i plus 5 plus 3i. Combining like terms says reals to reals, imaginary to imaginary. So I have my reals up in front. So this is actually negative 12 plus 5. And then I have my imaginaries. So I have the I terms. So minus 4i plus 3i. When I combine them together, I have negative 12 plus 5 is a negative 7. And then negative 4 plus 3 becomes a negative I. And this would be that final answer. Notice this is in standard form. Of A plus or minus BI. So no matter what you do, you are always trying to strive for that standard form equation. Now if we look at this second one, notice I don't have any i's. So the first thing I have to do is make them. So here I have a negative, which becomes an I, and same with this. I have my negative, which becomes an I. This means I have 7 minus I square roots of 36, and then this is minus 2 plus I square roots of 9. Well, square root of 36 is going to reduce, so this is going to become 7 minus 6i, and then minus 2 plus 3i. Once you get down to this form, now you can combine. Okay, so here, the first thing we had to do is we had to translate the negative radical into the I form. Then the second thing that you are going to do is you are going to combine, i.e. perform the operation given. This operation here has a negative, so this has to flow through the back half. So we have 7 minus 6i minus 2 minus 3i. Again, combine my terms, 7 minus 2, and then combine my imaginary terms, minus 6i minus 3i. 7 minus 2 is going to give me a 5. Negative 6 minus 3 is a negative 9i. The last thing you would want to do is double check, is this in the form A plus BI? And yes, it is. So this is standard form, therefore I have finished. Okay? So those are two examples of addition or subtraction using imaginary numbers. Now, as we all know, once you conquer addition and subtraction, the next one we look at is usually multiplication. Multiplication says that you have to use the idea behind FOIL or the distributive method in order to remove your parentheses. So we are going to combine like terms. So the first thing we have to look at is we have to look at the fact that we have to use FOIL, or the easiest method to use would be the FOIL method. So FOIL says first outer, inner, last. Okay? So let's go ahead and take a look at that. First says first two terms. So this is going to be 8 times a negative 2. We're going to add that to the next. Next is outer. Outer says I have 8 times 5i. I have to add that to my next, which says inner. Negative 3i times a negative 2, and add it to the last one, which is obviously last. Negative 3i times 5i. Once we do that, we are then going to combine our terms and simplify as far as we can go. So, if we look at it, we can continue on with what we have. So 8 times negative 2 is a negative 16. We're going to add this to the next. 8 times 5 is a 40, and we treat the I like we do a variable. Negative 3i times a negative 2 is a positive 6i. And then I have a negative 3i times 5i is going to give you a positive 15, and then I times I would be I squared. So the first thing we have to look at is the fact that we have some stuff to combine here. So when we look at it, first we need to combine my terms. So I have negative 16 plus 40 plus 6 makes it a 46i. We then have plus 15i squared. Well, one of the things that we know is that this I squared here is going to follow my rule, which says that I squared equals negative 1. So therefore what that means is we have negative 16 plus 46i plus 15, and then this is times negative 1. If we keep reducing, this is going to be negative 16 Sorry, I just noticed I made a mistake with my sign, and it's right here. This was negative, so this should be a negative, not a positive. So again, plus my 46i, and then this is negative 15 times negative 1 makes it a positive 15, gives me an overall result of negative 1 plus 46i. And this would be my standard form. Okay. So I do apologize for that oversight. The biggest thing that I can stress here, because I just made this mistake, is that signs are some of the most important things that are going to follow you through math. And it is very easy, notice in the beginning, to have mixed your signs up, and thus they carry you all the way through to the bottom. Now for me, unfortunately, because I've been working at this for so long, I kind of recognized that something wrong had happened and was able to catch myself. For anybody else working, after every step you do, you always want to go back and double check and make sure that you didn't easily overstep. Okay. Alright, before we get to division, we have to look at something else really quickly, which is that we have what's called the powers of I. So, powers of I is a pattern. So if you notice, if we have I squared, we know that that can break into I times I, and we also know it follows that rule that it equals negative 1. The powers of I sets up a pattern for how you would reduce different powers of I down to their smallest form. So for example, I cubed is the same as I times I times I. So if you look at it, you really have I squared times I. We know that I squared is -1, therefore it reduces to -I. We can use that same argument with I to the 4th, I to the 5th, and then I to the 6th. And what you should notice is that I squared and I to the 6th will simplify down to the exact same value. That means if we had gone one more, say to I to the 7th, you would find out that I to the 7th is really -I. I to the 8th would be 1. I to the 9th would be I. So it's a pattern that essentially repeats every 4. Well, the rule then boils down to the following. If I is raised to an odd power, then its reduced solution will be plus or minus I. However, if I is raised to an even power, the reduced solution will be plus or minus 1. And that's just going to depend on how it falls in the pattern. Now, we use this idea when we work with complex conjugates. A complex conjugate is the same as a regular conjugate. The only difference is the I is part of the conjugate here. So if I have 3 plus 4i, the complex conjugate says I'm going to keep the numbers and the I the same, but I am going to use the opposite sign. So the complex conjugate here would be 3 minus 4i. Now, if I want to be able to simplify the expression, then that means once you identify the complex conjugate, you then have to multiply with it. So this is going to become 3 plus 4i times 3 minus 4i. The goal is to remove your I from the problem. Okay, so that is the goal. So again, first, outer, inner, last. So first, 3 times 3, which is 9. Outer, 3 times a negative 4 is a negative 12i. Inner, 3 times positive 4 is a positive 12i. And then last, 4 times a negative 4 is a negative 16i squared. Well, what you should notice is that negative 12 and positive 12i, these are going to go away, thus leaving me with 9 minus 16i squared. I know this I squared right here is going to follow the rule that I squared equals -1. So this is 9 minus 16 times -1, which is the same as 9 plus 16, which equals 25. Let's look at the next one. Here I have 5 minus 6i, which means its complex conjugate is going to be 5 plus a 6i. So again, I'm going to take them and multiply them. 5 minus 6i times 5 plus 6i. First is going to give me 25. Outer is going to give me plus 30i. Inner is a minus 30i. Last is a minus 36i squared. Again, like before, my middle terms totally go away. Therefore, I have 25 minus 36i squared. I know my I squared here is going to follow the rule, which says that I squared equals -1. So this is going to be 25 minus 36 times -1, which is 25 plus 36, which equals 61. Okay, notice I don't have any i's. Last but not least, I have 8i. So when we're talking about 8i, its complex conjugate is a -8i. So again, we're going to do the same thing. So this is 8i times -8i. So 8 times a -8 is a -64i squared. We know I squared is negative 1, so this is a negative 64 times negative 1, which equals 64 as a result. Complex conjugates. Now all of that leads us up to dividing. Dividing says you cannot leave I in the denominator. So in order to divide, you have to multiply the top and bottom of your fraction by the complex conjugate. So here, when we're looking for the complex conjugate, you need to pay close attention that you use the right one. In this case, the complex conjugate would be negative 7 minus 2i. It's using the denominator and the opposite sign, and the only sign that changes is the operation, not the sign of the terms. So here I have to take what I've been given, so 5 minus I over negative 7 plus 2i, and I have to multiply the top, negative 7 minus 2i, and the bottom, negative 7 minus 2i. The biggest advice I can give you here is this. You want to check the denominator first. Since your goal is to have removed the I term from the denominator, that is where you want to start. Because if you've made a mistake in your calculations, the place it's going to show is in the denominator. So here, I'm going to look at my denominator. So I have 7 plus 2i and negative 7 minus 2i. So negative 7 and negative 7 is going to give me 49. Then my outers, negative 7 and negative 2 is a plus 14i. Inner is negative 2 or positive 2i and negative 7, which is negative 14i. And then last is going to give me a negative 4i squared. Well, if I look at those, the middle goes away, and I have I squared, which we know by the rule equals negative 1. Therefore, I have multiplied by the correct complex conjugate, so now you can go ahead and multiply the top. 5 times negative 7 is a negative 35. Do my outers. 5 times negative 2 is a negative 10i. Do the inners. Negative 1 and negative 7 gives you a positive 7i. And then last, positive 2i squared. And in this case, my inners do not go away, but I also have that I squared equals negative 1. So keep reducing. Across the top, I have negative 35. Negative 10 plus 7 is a negative 3i. And then this is plus 2 times negative 1. Take a look at the bottom. I have 49 minus 4 times negative 1. Keep reducing. 2 times a negative 1 is negative 2, so this becomes negative 37 minus 3i. Take a look at the bottom. Negative 4 times a negative 1 is positive. So we have 49 plus 4 gives us a 53. Here we have to remember standard form, which says A plus BI. So once we figured out our fraction, we need to write it in standard form. So this is negative 37 over 53 minus 3 over 53i. And this would be our standard form. So in a nutshell, that's kind of everything that you need to know about complex conjugates or complex numbers and how they work and what is required. So if you have any questions, please let me know. Otherwise, remember, math is bananas. So just keep smiling, ask tons of questions, and be sure to have lots of fun with your math. And as always, I'll see you next time.